Okay, so as promised, I wanted to go over some of solving absolute value and inequality equations, the ones that we didn't get to solve today in class. So anything like B and E, well, even G and K, remember that before we do any sort of operations, we want to make sure that we're getting the absolute value symbols by themselves. So I need to undo this 3 and I have to undo this -9 before I do anything with this absolute value. So if I undo the 3, that'll give me -9 times the absolute value of 3 minus 4x is going to be equal to 0. And then I want to divide each side by -9. So when I do that, that'll give me the absolute value of 3 minus 4x is equal to 0. So at this point, this is where I'd want to split my equations. But if I split this into two equations, remember that we want to keep one equation with the positive constant and one equation with the negative constant. If I try to split this up into two equations, it just gives me a 0. So this is a special case where when we have an absolute value equation, we're actually only going to end up with one equation because we're just going to set 3 minus 4x equal to 0. So when I go ahead to solve for x here, that'll be 3 is equal to 4x. So that'll give me an x value of 3/4. And don't forget that we always want to make sure that we are checking our solution in the original. So -9 times the absolute value of 3 minus 4 times 3/4 plus 3 is equal to 3. And remember, we're just simplifying. We're not solving. We're not moving anything from one side to the other. So this will give me -9 times 3 minus 3 plus 3 is equal to 3. -9 times the absolute value of 0 plus 3 is equal to 3. That'll just give me -9 times 0 plus 3 is equal to 3. So obviously -9 times 0 is just 0. So 3 is equal to 3. That means that 3/4 does work as a solution. All right, there was also a question on E. So that was the absolute value of 4 plus 5x over 3 is equal to -15. So again, I want to get the absolute values by themselves on one side. So I have to undo this 3. So I'm going to go ahead and do that by multiplying each side of the equation by 3. That'll allow me to get this fraction away. So that'll give me absolute value of 4 plus 5x is equal to -45. And actually at this point, I don't need to do any more work because we talked about no matter what you put in these absolute value symbols, if it's negative or if it's positive, remember that when we take the absolute value is always positive. So no matter what we put in here, we're never going to get an absolute value that is going to be negative. So in this case, you actually don't need to show any more work. You can just write no solution. If you wanted to split up the equation at this point and say 4 plus 5x is equal to -45 and 4 plus 5x is equal to +45 and solve these out and get two x values and then check them, they wouldn't end up being solutions in this equation. So if you want to go ahead and do that, you can. You don't need to. You do not actually need to show any of this work if you do not want to. At this point, once you have the absolute value bars by themselves, it's equal to a negative. You can automatically say there's going to be no solution. All right, so then there's a couple of inequality ones that were questions that came up in class today. So the same idea with this, before we do anything with the inequality, want to make sure that we are getting the absolute value bars by themselves. So I have to undo this 5, I have to undo the 3 before I do anything with this. So I'm going to go ahead and undo the 5 first. So if I subtract that from each side, that will give me a 9. And then I'm going to go ahead and get rid of the 3 on the left-hand side by dividing it out. So that'll give me the absolute value of -2x plus 7 is greater than 3. And at this point, now that I've gotten the absolute value bars by themselves, this is when I can go ahead to decide what rule it is that I'm going to use. So since this is a greater than, this is where I want to break it up into two different inequalities. So the first one is going to be -2x plus 7 is greater than 3. So it just stays exactly the same way that it is. I'm just dropping the absolute value bars. Or -2x plus 7, I'm going to flip the inequality, so less than, and I'm going to change the sign of the constant, so -3. So at this point, I want to go ahead and just solve these as I would for normal inequalities. So get the x by itself. So -2x is greater than -4. Be careful here because when you do the next step and you divide by this negative number, your inequality symbol is going to flip. So when I divide each side by -2, this is going to give me an x is now greater than a +2. Because anytime you divide by a negative, your inequality symbol has to flip. Over here, I'm going to go ahead and subtract the 7. So 2x is going to be less than negative 10. And same idea over here. When I'm undoing this negative 2 by division, I have to flip this inequality symbol. So that's going to give me an x is now greater than positive 5. So when I go to check these, remember that we want to make sure that these are going to end up working. I'm just going to pick an x value that's greater than 2 or an x value that's greater than 5. Whoops, this should have flipped. That should be x is less than 2. Sorry. X is less than 2 or x is greater than 5. So my check for my first inequality, I'm going to pick a number that's less than 2. So I'll just choose I'll choose x is equal to 0 because that's easy. So 3 times the absolute value of negative 2 times 0 plus 7 plus 5 is greater than 14. I'm just going to simplify here. So 3 times the absolute value of 7 plus 5 is greater than 14. That gives me 3 times 7 plus 5 is greater than 14. So that's 21 plus 5. So 26 is greater than 14. So that does work. The x value is less than 2. I also need to check my other one. So I want to check x is greater than 5. So I'll choose, I don't know, I'll use x is equal to 6 to check that one. So 3 times the absolute value of negative 2 times 6 plus 7 plus 5 greater than 14. So that'll give me 3 times the absolute value. That's negative 12 plus 7. So negative 5 plus 5 is greater than 14. This gives me 3 times positive 5 when I take the absolute value. So 15 plus 5 gives me 20. That is definitely greater than 14, so that does work. So my solution would be x is less than 2 or x is greater than 5. And this is how you should be writing out your solution. I should be seeing something like this. X is less than 2 or x is greater than 5. All right, and then the last question was K. So same idea for this one. We want to make sure that we're getting rid of anything that we need to get rid of around these absolute value symbols first. I did take one step and I did subtract the 2 from both sides before I wrote this equation, just so that you guys know where that negative 70 came from. But I do need to go ahead and divide each side by negative 10. And again, when I am dividing by a negative number at this point, I'm going to carry down the absolute value of negative 9x plus 7. But I'm going to go ahead and flip my inequality symbol because now that I've divided by a negative 10, my inequality symbol does have to flip. So less than or equal to 7 when I do that division. So now that I've gotten the absolute value bars by themselves, I can investigate and say, okay, this is a less than or equal to inequality. So this is where I'm going to go ahead and do the compound. So my compound is going to be negative 7 is less than or equal to negative 9x plus 7. Which is less than or equal to positive 7. And then I can go ahead and solve this inequality. So I'll go ahead and subtract 7 from all sides. So that'll give me negative 14 is less than or equal to negative 9x, which is less than or equal to 0. And then I'm going to go ahead and divide each side by negative 9. But again, because we are dividing by a negative number, make sure that when you are dividing, these symbols are also going to flip again. So this is going to be, I'm going to simplify this. So 14 divided by 9 is going to be now greater than or equal to x, which is going to be greater than or equal to 0. So again, notice that both of these inequality symbols did have to flip. So I'm just going to write this a little bit better because generally we like writing the lower value first and the upper value second. So this is going to flip and be 0 is less than or equal to x, which is less than or equal to 14/9. So then I just want to make sure that these values are going to work. So I'm going to figure out what x value I can check that's between 0 and 14/9. So I believe 1 is in there. So I'm going to check an x value of 1. I'm going to check it back up in that original. So negative 10 times the absolute value of negative 9 times 1 plus 7. I think minus 2 is greater than or equal to negative 68. So negative 10 times the absolute value of negative 9 plus 7 minus 2 greater than or equal to negative 68. That'll give me negative 10 times the absolute value of negative 2. So that'll give me negative 10 times 2 minus 2 And when I simplify that, what is that? Negative 20 minus 2. So negative 22 is greater than or equal to negative 68. That is a true statement because if you think about what's going on here, on a number line, negative 68 is over here, negative 22 is over here. So negative 22 is definitely greater than negative 68. So this ends up being a compound inequality that says x is somewhere in between 0 and 14/9. And again, I should be seeing your answer like this because it was a, when we got the absolute value bars by themselves, it was a less than or equal to, so you should be ending up with a compound inequality. So I hope that helps with that one. Please let me know if you have any more questions or if you have any questions on the solving ones.